Hello, good morning to everyone. I am Aubrey Sanico, your professor for today, and I am here to give you knowledge about kinematics. Today we will define kinematics, define scalars and vectors, distance and displacement, speed and velocity, and lastly acceleration. We will also compute and solve problems. What is your understanding of the word kinematics? Kinematics is the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. Kinematics is a branch of mechanics. It is the study of the motion of points, objects, and group of objects without considering the causes of its motion. Kinematics can be abstracted into purely mathematical expressions which can be used to calculate various aspects of motion such as velocity, acceleration, displacement, time, and trajectory. In kinematics, we will study such terms such as scalars, vectors, distance, displacement, speed, velocity, and acceleration. These words are used with regularity to describe the motion of objects. Our goal should be become to be very familiar with their meaning. So let's begin. First is scalar. Scalar are quantities that are fully described by a magnitude or numerical value alone. Second is vectors. Vectors are quantities that are fully described by both magnitude and a direction. In scalar, we have mass, length, distance, speed, power, energy, and work. In vector, we have displacement, velocity, acceleration, force, weight, friction, and momentum. Next is distance and displacement. Distance and displacements are two quantities that may seem to mean the same thing, yet have distinctly different definition and meanings. Distance can be defined as the total movement of an object with no regard to direction. We can also say distance is the amount of ground an object has covered from its starting point to its final destination. A distance can also be seen as a scalar quantity, that is, the distance of an object does not depend on the direction of its motion. It is the complete path traveled by an object. Next, displacement simply refers to the change in position of a particular object. For instance, an object moves from point A to point B. Through that process, displacement has occurred. Displacement represents a vector quantity and it has both magnitude and direction. Later in the problem solving, we will discuss how we can get the distance and displacement. But for now, let me discuss to you what is speed and velocity. Speed is a scalar quantity that refers to how fast an object is moving. It is the rate at which an object changes its location. Like distance, speed is a scalar because it has a magnitude but not a direction. Because speed is a rate, it depends on the time interval of motion. You can calculate the speed time or the change in time of motion as the difference between the ending time and the beginning time. Next is the velocity. Velocity is a vector quantity that refers to the rate at which an object changes its position. Velocity describes the speed and direction of an object. As with speed, it is useful to describe either the average velocity over time period or the velocity at a specific moment. Average velocity is displacement divided by the time over which the displacement occurs. Velocity, like speed, has SI unit of meters per second, but because it is a vector, you must also include a direction. Let's now move on to the example. A marble rolls 5.2 meters in 1.8 seconds. What was the marble average speed? Let's try to solve. And this is the formula. Average speed is equal to distance over time. Let's now substitute 5.2 meters over 1.8 seconds is equal to 2.9 meters per second. Next is the sample problem in velocity. A student has a displacement of 304 meter in north in 180 seconds. What was the student's average velocity? This is the formula. Delta D over delta T is, and now let's substitute. 304 meters over 180 seconds is equal to 1.7 meter per second. Lastly, we have acceleration. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. Acceleration rate at which velocity changes with time in terms of speed and direction. A point or an object moving in a straight line is accelerated if it speeds up or slows down. Motion on a circle is accelerated even if the speed is constant, because the direction is continually changing. This is the formula and how you will get the acceleration. Average acceleration is equal to final velocity minus starting velocity over time, equal to delta velocity over delta time. Let's move on. Let's now proceed and know the formula and how you will get and solve distance, displacement, speed, velocity, and acceleration. And these are the formula to solve the problems. Problem number 1. An airplane accelerates down a runway at 3.20 meter per second square for 32.8 seconds until it finally leaps off the ground. Determine the distance traveled before takeoff. As you can see in the picture, given is the given are acceleration is equal to 3.20 meter per second square, time is 32.8 seconds, and initial velocity is 0 meter per second. What we need to find is the distance, and the formula to find that is distance is equal to initial velocity multiplied by time plus 0.5 multiplied to acceleration and 2 times squared. Let's see the solution and substitution. So let's substitute the given. Distance is equal to 0. Distance is equal to 0 meter per seconds multiplied by 32.8 seconds plus 0.5 multiplied by 3.20 meter per seconds multiplied to 32.8 seconds squared. So the final answer is, or the value of the distance is 1721.5. We get 1721.5 as the value of distance. Next is problem number 2. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. The given in problem number 2 are 110 distance is equal to 110 meters, time is equal to 5.21 seconds, and initial velocity is equal to 0 meter per second. What we need to find is acceleration, and the formula is distance is equal to initial velocity times time plus 0.5 times acceleration times time squared. So the solution and substitution. So let's substitute. 110 is equal to 0 meter per second times 5.21 seconds plus 0.5 times acceleration times 5.21 seconds squared. Acceleration is equal to 110 is equal to 0.5 times 5.21 squared times acceleration. 110 is equal to 13.57 seconds square times acceleration. Acceleration is equal to 110 meters over 13.57 seconds square. The value. So the final answer or the value of acceleration is 8.10. We get 8.10 as the value of acceleration. Next is problem number 3. Upton Chuck is riding the giant drop at Great America. If Upton free falls for 2.60 seconds, what will be his final velocity and how far will he fall? The given in problem number 3 is acceleration is equal to negative 9.8 meters, time is equal to 2.6 seconds, and initial velocity is equal to 0 meter per second. What we need to find is distance and final velocity. Formula: D is equal to initial velocity times time plus 0.5 times acceleration times t time squared. And the formula for final velocity is initial velocity plus acceleration times time. Let's now proceed to the solution and substitution. D is equal to 0 meter per second times 2.60 seconds plus 0.5 times negative 9.8 meter per second times 2.60 squared. So the final answer that we will get in that problem is D is equal to negative 33.13. Next is the final velocity. 0 plus 0 times 9.8 meter per second times 2.60 seconds. The final answer or the value of final velocity is 25.5 meter per second. For R, initial velocity is equal to 18.5 meter per second. Final velocity is 46.1 meter per second and the time is 2.47 seconds. What we need to find? Distance and acceleration. The formula is acceleration is equal to delta V over time. Let's now proceed to solution and substitution. A is equal to delta V over time. A is equal to 46.1 meter per second minus 18.5 meter per second over 2.47. The final answer that we will get is 11.2 meter per second square. That is the final answer and the value of acceleration. Let's now proceed to the distance. Distance is equal to initial velocity times time plus 0.5 times acceleration times time squared. D is equal to 18.5 meter per second times 2.47 plus 0.5 times 11.2 meter per second square times 2.47 seconds square. D is equal to 45.7 to 0.5 times 11.2 meter per second square times 2.47 seconds square. The final answer or the value of distance is 79.9 meters. That's all in our problem solving. Here's an easy way to remember our formulas. Let's now keep a note and try to remember the formula that we need to use to solve our problems. Tomorrow, we will apply these concepts to more complex problems. Thank you for listening and watching this video. Again, I am Aubrey Sanico from CE1A12. And again, thank you for listening.